Hello team, in this lesson we are going to learn how to implement OAuth and OpenID Connect in Spring Boot application. In previous lessons we already learned the most important terminology and concepts, such as OAuth, OpenID Connect, JWT tokens, and identity providers. Even more, we already had a separate lesson to configure identity provider. If you are familiar with those topics, you can proceed with the lesson. But if you feel some gaps, please ensure you're watching those lessons first. So here's what we'll be going through in today's session. We'll start by setting up a Spring Boot project from scratch and make sure all the essential configurations are in place. Then we'll move on to adding the necessary dependencies, particularly those that enable OAuth2 integration, including both the client and resource server starters. Once the setup is ready, I will walk you through how the OpenID Connect client flow works in practice, and we'll run a live demo to see it in action. You'll also learn how Logout works, both from your application and from the identity provider, and how to configure it correctly. Next, we'll shift gears to explore the machine-to-machine flow, another common OAuth2 scenario, and see how it differs from interactive login. I'll guide you through the setup and show you how two applications can communicate securely using tokens. After that, we'll review how to configure the OAuth server and go through all the key Spring Boot properties that influence OAuth behavior. You will learn which configurations are essential, what their default values are, and when you might want to override them. By the end of this session, you'll have a solid understanding of how to integrate OAuth2 into a Spring Boot application, both for user login and system-to-system communication. So let's dive in. And I suggest to start from the live demo straight away. We already had enough of theoretical lessons. I also need to make one comment. Taking into account this course is created for engineers of different levels, there are basics and advanced lessons. In this lesson, I will not teach you how to create Spring Boot project from scratch, how to configure IDE support and other basic things about the Spring Boot. In this lesson, I will focus only on the topic that I stated in agenda. In case you want to learn Spring from scratch, please check my full course about Spring Framework or check other available lessons about Spring in the course, including annexes to the course. Okay, so for today's example, I created a Spring Boot project. Feel free to use latest available Spring Boot version. In Spring, we don't implement the OAuth2 protocol from scratch. Thankfully, that complexity is abstracted away for us. Instead, we rely on Spring Security's built-in support for OAuth2 and OpenID Connect, which comes through well-maintained modules. By simply including the correct dependencies, we unlock a full set of tools and pre-configured mechanisms that handle authorization flows, token exchanges, redirection, and even session management. So what exactly do we need to add as a dependency? In the world of OAuth2, applications can take on different roles depending on what they are responsible for. When working with Spring Boot, this distinction is captured through two separate starters: Spring Boot Starter OAuth2 Client and Spring Boot Starter OAuth2 Resource Server. Each one serves a unique purpose, and understanding their roles is critical to choosing the right configuration for your application. Let's start with the OAuth2 client. When your application needs to authenticate users, that is, redirect them to an external identity provider, allow them to log in, and then process the returned tokens, you're acting as an OAuth client. In this case, you add the OAuth2 client starter. This allows your application to participate in the authorization code flow, handle user sessions, and obtain both ID tokens and access tokens. It's commonly used in interactive web applications, sync login forms, dashboards, or any user-facing interface. On the other hand, we have the OAuth2 Resource Server. This is a very different role. Here, your application is not initiating authentication flows. Instead, it acts as a protected API. It receives requests that include an access token, typically a JWT, and its job is to validate that token and enforce access control. For this scenario, you include the OAuth2 Resource Server Starter. It enables your application to inspect incoming bearer tokens, confirm their signature and claims, and then decide whether to grant access to specific endpoints. So, should you use one or both? That depends entirely on the role your application plays. If your app just handles user login, the client starter is enough. If it only exposes APIs secured by tokens, then the resource server is the right choice. And if your application does both, say it authenticates users and also exposes APIs to other services, then it's perfectly valid to include both starters. In essence, this is about assigning the correct identity and responsibility to your application in the OAuth2 ecosystem. Understanding this division ensures that your authentication and authorization flow is both secure and correctly structured. So, as you can see, in the POM XML file I added these two dependencies. By the way, feel free to find all source code examples from the lesson in attachments to the lesson. These starters bring everything we need to configure our application as an OAuth2 client and server. They set up the logic for redirecting users to the identity provider, handling the callback, exchanging the authorization code for tokens, and storing the security context. All of this becomes available to us with a few lines in our build file. Whether you're using Maven or Gradle, this small step, adding a dependency, may seem minor, but it lays the groundwork for everything that follows. Without it, Spring wouldn't recognize your intention to participate in the OAuth2 flow, and none of the automated configuration would take place. So by including this dependency, we tell Spring, this application is going to act as an OAuth2 client and server. And from that point on, Spring Security takes care of much of the heavy lifting behind the scenes. For demonstration purposes, I will also include the TimeLeaf and Spring Web dependencies. These additions will allow us to render simple HTML views directly from our application and to simulate real-world authentication scenarios more clearly. With TimeLeaf, we'll be able to present login status, user information, and logout behavior in a structured UI, making the flow of OpenID Connect more intuitive and visually traceable. As you might recall from our previous lesson, we have already configured an identity provider, in our case OAuth0, so we won't repeat that step in this lesson. Instead, we are focusing on implementing the OpenID Connect flow in a Spring Boot application. We started by defining some essential properties in our application configuration, specifically in the application.properties file. Let's elaborate on each of these: client ID and client secret. These two fields uniquely identify our application when it communicates with the identity provider. OAuth0 provides these values, which ensure secure communication. Scope, we set it to OpenID, profile, email. The keyword OpenID explicitly activates OpenID Connect, instructing OAuth0 to issue an ID token. The profile scope allows access to standard user attributes such as name, family name, and locale, while the email scope gives access to the user's email address and its verification status. In addition to these, other valid scopes include address, which provides the user's physical address, and phone, which includes phone number information. You can also request custom scopes if your identity provider supports them, allowing access to application-specific user claims. All scopes must be separated by commas in the properties file. Redirect URI. This URL-based URL, login, OAuth2, code, OAuth0 is crucial. After authentication, OAuth0 redirects the user back to our application through this endpoint, allowing our app to handle tokens securely. Spring Security automatically handles this callback. It intercepts the request, exchanges the authorization code for tokens behind the scenes, and creates an authenticated session using the information contained in the ID token without any manual intervention on our part. Client name. This simply labels our OAuth client for clarity, especially useful if we have multiple providers configured. Authorization grant type. We've chosen the authorization code flow, considered the most secure option because it keeps tokens away from the browser and securely exchanges a temporary authorization code. We learned different grant types in the previous lesson. So if you want to learn more about different grant types, please check another lesson. Issue a URI points to our OAuth2 tenant URL. It helps Spring Security discover endpoints to interact with OAuth2 dynamically. Next, we set up a simple controller, our home controller. Let me open another Java class and walk you through the implementation. And just a reminder, in case you will have any questions regarding lines of code here, please post them in comments to the video and I will be happy to answer. So, the line with annotation getMapping defines the root endpoint of our web application. Within this method, we use another annotation, authentication principal with method parameter OEDCUser to access the authenticated user's details provided by OpenID Connect. If authentication is successful, Spring injects an instance of OADCUser. Then we pass this user to the view by adding it to the model with addAttribute method. Eventually, this returns our home view, leading us to the HTML page. Speaking about HTML, let's look at our home HTML. By default, Spring Boot looks for HTML files within the templates folder under the resources directory. Our home HTML uses TimeLeaf, a template engine integrated with Spring Boot. This page checks if a user is logged in using TimeLeaf conditions, like you can see in the line number 8. When the user is authenticated, it displays their full name and email address fetched from the OIDC ID token. If no authenticated user exists, a simple login link is shown, directing the user towards OAuth2's login page. Notice we have two logout options, OAuth2 logout and full logout. The difference here is subtle but critical. Clicking OAuth2 logout typically logs you out of your local application but might not terminate the session with OAuth2 itself. Meaning if you try to log back in, you might be auto-authenticated without re-entering credentials. However, full logout ensures both your local session and the OAuth2 session are fully terminated, effectively requiring the user to re-authenticate completely next time. To perform this complete logout, we have implemented a logout controller. The method inside it, mapped to custom logout, first uses Spring's security context logout handler to clear the local security context, local session data. Next, we construct a special logout URL that OAuth2 understands. This URL includes our application's client ID and a return to URL to which OAuth2 redirects users after successfully logging them out. We redirect the browser to this URL, clearing the OAuth2 session as well. Remember, we haven't explicitly defined a custom security configuration. I'm talking about security filter chain bean. Instead, we rely on the default security configuration provided by Spring Security through our starter dependencies. Due to this default behavior, all resources are protected, and any page request requires authentication via the OAuth2 authorization form. So, basically, after the logout, you will be asked to log in again to access the home page where our request is redirected. If you want to change this, you need to override the bean of security filter chain to allow everyone access selected resources, like homepage for example. Finally, let's summarize our practical demo scenario clearly. When a user accesses the homepage of our application, Spring Security detects that the user is unauthenticated and redirects them to OAuth2's login form. The user must enter their email and password, which we previously set up directly in our OAuth2 identity provider. Upon successful authentication, OAuth2 redirects the user back to our application using the callback URL we've configured. At this point, our application retrieves the user's information from the ID token provided by OAuth2, displaying these details on the home page. When the user decides to log out using our full logout option, they're redirected to OAuth2's logout endpoint. OAuth2 logs the user out of the identity provider session and then safely returns them back to our homepage, which requires him to log in again. That's how my simple OpenID Connect example looks like. In OAuth2, we previously set up our application settings to specify valid URLs for login callbacks and allowed logout redirects, ensuring secure and reliable user flows throughout. Let me now open the browser and walk you through this flow. But before opening a browser, let me run the application. And once it will be started, we can proceed with the demo. Let me open the web browser now. I reach home page of my app deployed on my local host. And as you can see, my request was redirected to the login form provided by OAuth2. I need to use the same email and password that I used to create a user in the previous lesson. Alternatively, you can use a Continue with Google button. Once you entered login and password, just click Continue button. And after the authentication, you will be able to access home page where the user details are printed. Now if I click OAuth2 Logout, I see form generated for me. I have been signed out from the application, but my session with identity provider is still active. So in case I try to request home page again, I'm authenticated again without the need to enter email and password again. To log out both from application and identity provider session, I need to use my customer endpoint that I already showed you. That's why now I will click on the full logout hyperreference. The logout will be performed, and as configured, I will be redirected to the home page. But to access the home page, I need to be authenticated. That's why the login form appears again. If I will navigate to the home page by entering address manually again, I will be redirected to the home page and again to the login form. That's how it works. Actually, that's all what I wanted to show you with regards to OpenID Connect demo. In case you still have any questions regarding the demo, please let me know and I will be happy to answer. And now let's move on and take a look how OAuth can help us to secure our API endpoints and how to build machine-to-machine secure communication.